I am running the Koolance PMP-400 DDC 18 watt pump in this particular case, and I have a few notes about that. For starters, I first ordered from frozen CPU, and my first pump absolutely would not work out of the box. I was testing it off of 12 volt mATX on a power supply on my test bench, and it would not power on. Frozen CPU, even though my item was defective, they wouldn't give me an advanced replacement, but they would give me 20% refund and would allow me to reorder. I instead found out, actually, from one of the customer service reps at Frozen CPU that Koolance sells the PMP-400 for $10 less than Frozen CPU. They're closer to me because they're in Washington and I'm in California, so shipping was less. So I just returned it, took the 20% hit at Frozen CPU, and then got it directly from Koolance and had it overnighted to me. Second pump worked absolutely perfectly right off the bat on 12 volt mATX. Couldn't be happier. I really wish my first pump would have worked, but anyway, this one does. So moving forward, another couple notes on this particular pump. You want to go with Koolance, in my opinion. SwiftTech has some really nice DDC pumps. The MCP-35X is great. It has full PWM via your motherboard header. Fantastic accessories in the kit. It's a great pump. The only issue is SwiftTech's warranty on these pumps is terrible. As soon as you replace the top on a pump with SwiftTech, they will not warranty you in any way, shape, or form. Koolance will allow you to replace the stock top on this DDC pump with any other Koolance top or reservoir product. For example, this RP-401X2, which we'll get to in a couple of seconds, and they will still warranty your pump fully, which is really great. So I recommend going Koolance, because if you're paying $65 to $90 on a small pump that has a very poor mean time between failures, these pumps, on average 50,000, which is very low for a component. You really want that warranty. This is a mechanical part that definitely can fail, and it will fail on you. So this is the same top on this, the original top, as old DDC pumps, nothing special with the accessories. It's a DDC 3.25, which is the latest revision. It's got excellent flow rate and head pressure, incredibly small form factor, much smaller than a D5 Vario type pump. At full bore, 18 watts, 12 volts, this pulls 1.5 amps in terms of current. And it'll differ, of course, per pump, but the startup voltage is around 9 to 10 volts. I got unlucky. I can't get just under 9 volts. I really need closer to 10 volts to get this pump going. And again, that will vary a little bit, but it'll be between 9 and 10 volts to get your pump going. To control this pump, you're going to want to look at getting a Koolance CTR controller or any fan controller that can generally handle at least 20 watts. I really strongly don't recommend using one of your spare inline resistor 3-pin adapters, like I know come with a lot of fans. The Noctua fans have those, because going back to high school physics, we know that one of those adapters, those small inline resistors, it will not be able to dissipate enough heat, or rather, it won't be able to dissipate the power load necessary. So you're going to have one of those little resistors that'll be able to appropriately dissipate, 0.5 watts or something is what it'll be rated for. And you're going to be putting 18 watts. It's going to burn up. It's going to melt. You're going to have a really bad time. I've seen it happen with some of the big Delta fans. Those inline resistors go bad real quick. You also want to be wary of using a rheostat. A lot of those controllers can burn up with pumps. And the other downside of a lot of those types of controllers is you'll have to start up the fan at full voltage, so 12 volts, and then once your computer's running, you'll then have to decrease the voltage. You can't set it to a lower voltage and have it automatically work like the Koolance CTR controllers do, or their computerized controllers as well. So at full bore, this pump runs at about 4,200 RPM, and that's full duty, at about 60% duty. And of course, this isn't PWM, so by duty, that I'm just talking at, around 6 volts. You're going to get to 2,700 RPM. No matter what, at the end of the day, my pump does have an electronic whine noise that comes from the motor. The sound is easily dampened. As soon as I put a top cover on here, or even just place my hand right over the pump, the whining sound is inaudible, so that's really great. You could even put a piece of foam up there, but I'd be worried because this pump at 18 watts gets very hot. You'll notice I'm doing something kind of dangerous. Most people don't do this. I am running my pump at the moment for testing off of my motherboard fan connector. These fan connectors are rated at 1 amp current draw, so I'm pushing it a little bit. I'm currently running my pump at 6 volts, so besides startup, it should be okay. I'm not sure how their voltage regulation is or how their wind bond controller works for the fan controller on this board, so it may be keeping the current constant no matter what, and I do run the risk of damaging my fan controller header, so I need to be careful with that, and I am planning on getting a CTR very soon to run on this top bay here. Most likely when I go in SLI or I get a serial pump and then run those 2 pumps up the fan controller, I'll get that in here. So 60% duty, around 6 to 7 volts, pretty quiet. It sounds about like a 1200 RPM 120 millimeter fan, which, you know, pretty nice if you're sitting right next to it, not bad at all once you get past a bit of a whine. Again, it would be nice to have that PWM directly, as on the MCP-35X from Swiftech. And interestingly enough, this particular pump, I don't know if the controller on here works with PWM. It has 4 solder points on the back of the PCB, which to me, based on this coloring scheme, indicates that that middle solder point would be to allow you to have full 4-pin PWM. But again, a lot of these pumps, they have that pad, that solder pad, but the controller on board doesn't support direct PWM. And in fact, this pump most likely doesn't, because I know they combined some of their power draw directly over the line that they use for reporting speed. So I would be really careful if you tried to mod the fan or the pump to work with PWM. In fact, it probably won't work. Yeah, it's a really great pump. One thing to keep in mind, if you're really concerned about noise, you might want to get a 10 watt DDC. If you're running a big rig, of course, that won't cut it, and you will have to step it up to something like a D5. But honestly, with 2 of these running serially, if you keep them at 60% duty, 6-7 volts, and you have that top cover on and your case is sealed, I'm really picky about sound, but you really won't hear this pump running. I think it's very quiet. So let's go ahead and talk about this reservoir a bit here. This is the Koolance RP-401X2. Incredibly large mass, so it stifles most of the resonance of this pump. This is some of the best quality machine work I've seen on a bay reservoir. They're normally quite bad. This is full acetyl. It's beautifully made, incredibly sturdy and rigid. Fantastic. Again, it supports serial pumps, so you can run the reservoirs separately. You can run them combined, which I don't recommend because that will reduce some of your flow. You can run 1 reservoir with 2 pumps serially, and you can get the serial pump kit from Koolance, which I think should be included in my opinion. So those are the options you have with this. It's pretty crazy to have a single 5 1/4 inch bay reservoir pump combo with 2 pumps running in it. It's very impressive. So a few notes about this reservoir. The front of the reservoir, let's just take a look at that. As you can see, beautifully machined aluminum front, and that front screws directly onto an acetyl backing that is very thick. I can't remember how many millimeters. Very sturdy. This will help decrease the pressure all along the acetyl, so hopefully this will not leak. This new revision also added front filled drain ports, which is great, especially if you're like me and you planned your build around those. And then you also have, each of the reservoir has filled drain ports right on the top here, and these are threaded, of course. Now this RP-401X2, I prefer it much more to the dual bay reservoirs, because a lot of the dual bay reservoirs that people are getting, like the XSPC D5 dual bay reservoirs that are D5 oriented, The quality is not great. They vibrate and hum. They transfer vibration to the rest of your chassis because of how they're designed. They're not solidly milled. They use vinyl to seal around the acetyl to save money. And that vinyl glue has worn off on many people's D5 bay reservoirs. And it will leak. There's many pictures all over the internet, Hardform, overclock.net, and you'll see people with their XSPC bay reservoirs and they are leaking coolant, and it's very sad. I also prefer this actually to the RP-402, which is the dual bay D5 version of this that Koolance has, because this is much easier to bleed. Everything I've read about the dual bay 402 says that it is practically impossible to bleed. They even make a kit. They sell a bleed kit that you have to buy separately, where you have to modify the acrylic blocker inside, and it's pretty cumbersome. So I prefer this setup quite a bit. So then some actual notes about bleeding and priming the pump and filling. This reservoir is very small, so it is a little bit difficult to get this filled. And in the same way it's difficult to make sure your pump is properly primed, I strongly recommend running an external power supply and power cycling your pump and tilting the case upwards to make sure that the rest of your loop is filled. Because if the rest of your loop, including your reservoirs, isn't properly filled, you will be running this pump dry, no matter the fact that it looks like there's water in your reservoir. You will run this pump dry. You will kill this pump. So you need to be very careful. In terms of bleeding, I would have to say that while more difficult, still less difficult than those D5 bay drives, it took me about half an hour to manually shake loose most of the air bubbles in my tubing. After doing that, and I recommend shaking side to side and constantly power cycling, make sure you run your pump on a lower speed if you have a fan controller. That really helps keep the air forced out of the top instead of pushing the air back through the pump. And you'll know when this pump is primed and running correctly because it will stop sounding incredibly frightening. So, you know, that's another thing to keep in mind. You'll know when your pump is working. So for bleeding, you shake it back and forth about 20-30 minutes. This is my first water cooling build in a long time, so keep in mind I am, you know, new to a lot of things, a lot of different components. And after doing that, I left my build running. Of course, after leak testing, I ran my build running overnight, and after that, most of the micro bubbles were gone. So from there on, it was just a couple days of maintenance, just checking the reservoir levels, but it generally bled pretty easily. It wasn't as good as having a standalone reservoir from what I remember, but not bad at all, honestly. Very easy to bleed. A little bit more advanced in your vigorous shaking techniques you'll need for it, but not bad. So now that we've taken a look at the reservoir and the pump, let's go ahead and talk about the other components in this build.